So welcome back. We've installed Cassandra, and by this time I expect that you have it running. You can connect to it from your sandbox because now we want to go back to the use case, which is looking at the uh, vehicle test data from the United Kingdom's Ministry of Transport. So we want to take the simplest test case, and I think I'll break it down from there. So to connect Spark with Cassandra, you need a Spark connector. And let's talk about connectors. Connectors are not concepts that are just related to Spark. They are concepts that are related to a lot of these general computing frameworks that don't in themselves have storage. So with connectors, they can connect with other forms of storage. You want to take example Hive. Hive has a way of connecting to HDFS. It also has a way of connecting to MongoDB, to HBase. It has a way of connecting to Amazon S3 file system and other forms of file system or even databases. Hive can connect to JDBC databases. So once a general computing platform doesn't have a storage system in itself, it provides connectors so that it can integrate. And the larger the number of connectors, the wider the adoption. So it's important for connectors to exist. So Cassandra Spark is a general computing framework and a platform. It doesn't have a storage on its own, so it provides connectors. So there are many ways to create connectors in Spark. Two very common ways of doing that, remember, in Spark, is either you're dealing with RDDs or you're dealing with data frames. It's either you're dealing with RDDs, data streams, data frames. So if you're doing Spark code, you're dealing RDDs. If you're doing Spark Spark streaming, you're also doing RDDs because D streams use RDDs. If you're dealing with Spark structured streaming, you are dealing with data frames. If you're doing graph frames, you're using data frames. If you're using GraphX, you are using RDDs under the hood. So it doesn't matter where you go. If you're using MLlib, you are using RDDs. If you're using MLlib or ML, you're using data frame under the hood. So these are the two fundamentals, RDDs and data frames. And even though data frames use RDD under the hood, the ways of writing data sources or connectors for data frames kind of differs from RDDs. For instance, with RDDs, all you need to do is expose a data type for whatever language you're using. So I'm sorry, a data structure for whatever type you're using. For example, if you're using, if you want to go through the MapReduce or the Hadoop corridor, then you'll be using inputs and outputs. For example, HBase, you have to use like table input format. For text files on HDFS, you have to use text input formats. So these properties are available in the Spark context. So that is one way. Where is it? You go something like Hadoop files, right? So you use input and output formats, and these things are very particular for Hadoop, right? So that is one way you can do it, and you would now provide data structures that will implement that data structures that will now be held in your RDDs. So that is one way. The other way to do it, which is to use things for data frame, right, is to create classes that can implement a Spark data frame writer in case of writing to the data source, or a Spark data frame reader if you want to read from it. And to do all those kind of functions, you have to implement like data sources, right? You have to implement data sources. So you find them in the Spark SQL data source writer. So it turns out that we rarely do these. Most people who do these are people like MongoDB, Tangent, the company. They provide a data source and they want adoption with the Spark platform. So they provided one that we used last week. DataStax, which is the big custodian of Cassandra right now, they also provided a connector. So why it might be interesting for you to understand how to implement it, because you can actually play around with some of these things. You literally don't need it, right? Instead, what you need to do is go read up the documentation for these existing stacks for these connectors, right? For example, you can see the Spark Cassandra connector that works with Spark, integrating it with Cassandra, right? Let me repeat, except you are implementing a connector of your own. For example, you want to connect Spark with Neo4j, or you don't like the one that's been done and think you can do something better. That's the only time you need to use this package, or this package within Spark, which is the Spark SQL data source. You can do RDDs, and I just told you how to do RDDs, but you can also do Spark data source. So this allows you to declare quite a lot of things, and implementing them will afford you the ability to move data either from a data source into your Spark application as a data frame, or to write an existing data frame back into your data source. We did it last week or last month's Hacker Day, and this Hacker Day we're using some. So if you don't have a need to read one, or to debug one, or to write one, you probably want to skip over and instead learn how to use one. How about that? So you can see this is the Spark Cassandra connector, and we're going to use it right now. So just make it bigger. You would see the instructions on how to use it. The features, I'm just going to jump to the instructions and just show you. We're going to try something on Spark Shell, right? And we want to use yarn. And let's jump to the quick aid guide. So I literally have it in my history, but I just want to walk you through. So I want to add the library. Because let's do this way. If I say help, what version am I using? Spark Shell help. It doesn't do like that. Something not right. Okay, sorry, not help. I'm sorry. Version. Spark Shell version. Good. So you can see I am using 2.11.8, the version of Scala, and Spark is 2.3.0. So I'm going to add something like this to Spark. And I have done this already, so it looks like this. So I say Spark Shell, the package is, I declare this. I'm not using the version because mine is different. I'm using 2.3.2, which is the next larger version. 2.3.2. So literally I'm trying to say I picked every of those stuff from here. I'm literally showing you the source. Then once you have done that, you one way to do this, since we're using Spark Shell, is to specify the configuration parameter spark.cassandra.connection.host. So you see, I'm using the IP of my machine now, right? So the IP of the host, the guy right here, IP, sorry, excuse me. I'm using the IP of the host right here. I say enter. If this is the first time you're using it, it's gonna take about 30 seconds to 1 minute because it has to download all the artifacts from the central repository, but it's fast for me because it's not the first time I am using it. So once you've done that, everything just goes along with this documentation, and pretty simple. Excuse me. So one thing I'm gonna do right here is kill this server. Yeah, it's been fun, and I'm gonna start the other server that I am running, Apache. So it's just a version less, being Cassandra, right? So it's just gonna start. It's that I already have data inside of that. So this server is gonna fire up, and I'm going to open. I'm gonna connect to it. I can connect. Okay, now I can connect. Show key spaces. Sorry, it's describe. Describe key spaces. And right here, I want to see what is in demo key space. So I have that called demo key space, and I'm going to use demo key space. If once in demo key space, let's see what we have. I have a table called user, just like the last one I did. Select star from user, and I have 3 records, right? This is a set, this is a string, this is a string, and if I describe user, you see my primary key is the last. Oh no, this is an index. My primary key is the first name, right? My primary key is the first name. So let's see if I can read this from my application, from my Spark workbench, so to say, my Spark console. So what I'm gonna do is copy this, the org.apache.spark.sql.cassandra, and I'm going to import this because it comes with a lot of implicit functions, and those implicits are what I really want to use. Once I import that, now I can see spark.read. Let's see what happened. You can see this one right here, Cassandra formats. So it's the implicit function that comes in. So what does it take? I don't know what it takes. Let's do this. And it takes 2 parameters. It takes a table, it takes the cluster, and a key space and a cluster. So I'm just going to take 2, right? So the first one is table will be user, key space will be demo key space, right? And I'm going to call this a data frame. Right, and let's see the schema and compare the schema with what we have. d.print schema. Oh, something is wrong. I didn't finish that. So once I do this, I should add .load. Sorry, I should add .load. That is when we get a data frame. So the first one did not give us a data frame. It gave us a data frame reader. So now if I say print schema, you see the schema, the first name is a string, last name is a string, and email is an array, which maps to what we have here. And if I say df.show and print all the values, you would see I'm literally going to Cassandra and I'm loading the data into my Spark driver. That is it. So the beautiful thing here is, remember the last query we wrote, and this is what I just want to say. Remember the last query we wrote, for example, we will say there's an index on this last name, so I can show you that with the last name. There's an index on this last name. Okay, so I'll show you later. So what I'm trying to say, once I have the data here, I literally can perform any Spark related operation here, even though Cassandra would not let me do it. When I am dealing with Cassandra one-on-one, I can do it here. And that's what makes it very, very, this is what makes them a match made in heaven. Because Cassandra would not offer you that, but now, behold, you can have that working for you here. So, having shown you this, let's take the simplest case and load a data into Cassandra. So we have a record, and by the way, let me show you. So this is the ERD for the test motor testing, MOT, Ministry of Transport Vehicle Testing data, right? And what we want to test is we want to model the lookup date tables. So we literally have the lookup tables test ID, and these are lookups. They are supplementary data. The only two data sets that yearly data sets that you get from that website is test item and test results. So what I did was I modeled this record, and we will see how the modeling goes. So just a bit of data crunching, and loaded this data using these simple APIs. Now, what I showed you is not all about the APIs. If you really want to know more about the APIs and all the flags that it takes, you can go into read the documentation more. I mean, you can see all the topics, so there's a lot to read. How to use it for streaming, how to map objects, how to use case classes and tuples. Even if you use things like user-defined types in Cassandra, how do you map it to Spark? How do you do performance monitoring? How to use embedded embedded Spark. This probably you want to do testing. You want to do UAT testing in your code base. So that, and how to use it for data frames. So these things are there. For example, how to map the split size of the data frames. All this Spark input split size, and how to use different clusters in one application. I mean, they're all there. How to set, once again, the consistency level. Those are things you have to decide from the read and write. You can see them there. However, we're just going to stick with this most basic one, and we are going to take the first try. So I already have this rough work done, and let's close Mongo. We are out of the realms of Mongo. Good. So we did that, and the data sets, like I said, we already have a script that we use to load the data sets. So if you come right here, you can see how we downloaded this data, downloaded the lookup data. So all we're dealing with now is just the lookup data, unzipped it and loaded it in these different locations. So when you see me referring to these locations here, and by the way, it's a CSV file, or rather it's a TSV file delimited with a pipe. So everything you see me doing here is we're working on this file. Good. So let's just do this. See what I did here. What am I trying to do? What am I trying to do? Remember, In Cassandra, you don't just go and start writing code and building tables. You must be guided by modeling, right? And we will leave the talk about modeling for our next section, but I want to show you a picture of what we want to do. So we have this ERD, and this is what we were originally given. That is one. Secondly, we have a list of sample queries that we want to tackle. Looking at this query, this is an analytical query. This query is also an analytical query, but this query is really not, right? So all the records here are from the lookup tables, and what they want to see here is the basic expansion of reason for refusal hierarchy for a class 5 table. So what this means is that this table is related to itself. For example, a parent ID of an item group maps to another record's test item ID. I am talking of this section here, right? So you can see this relationship. What they're saying is that it forms a hierarchy, and they want to get the 5 levels of hierarchies. So this means that they are left joining with the tables 5 times to get the parent, right? And if you do this for a large data set, remember this join is a lot, right? But it's a lookup data, it's not that much. So, but what we want to do is we want to store this data in Cassandra. Remember, there are no joins. So how do you have to store it in a way that there are no joins. This is where we do something with Spark. We read this data from HDFS, and we perform all this join and create one very flat table, right? One very flat table where all these parent records reside. So let's run it, and we will call it a day for now. Tomorrow we will we will drill down into the details, and that will be a lot more of Spark than Cassandra. Then we will see how to do this level of aggregation if possible. Then we will now complete all the exercises and ask ourselves the simple question: consider MongoDB, consider Cassandra. For this kind of analytical workload, which will you prefer? For data streaming workload, which will you prefer? Then we'll make that very broad conclusions from a more relaxed and informed perspective. Okay, so let's just get this working. So now I will take this data, and I'm just going to read all of them, right? So read. I read all of them. Then what I want to do here is I take this data and I create what I call the hierarchy. So I take one data frame, I cache it, then I declare 4 different aliases of that one data frame. So you can see base data frame as level 1, base data frame as level 2, base data. So they all get from one guy. And if you cache them, it means that you will be reusing only one instance of it. That's one reason why Spark has cache. Then all those left join you saw us do, or you saw in the query sample here. So we did inner join, then everything subsequently was a left join. That looks like what we did here. Left outer join, left outer join. Right? Then we did that inner join here. Oh, where's it? Inner join here. So we literally implemented this query here because we want to save it in a way that Cassandra will not have to do that join again. So, but here I wrote this as a method and just going to execute this. Enter. Should not fail, right? Everything there is just plain Spark SQL, right? So once you've done this, we now want to take these 2 data frames that we've done right? Paste it. So we now get a data frame text detail. Okay, test detail. This is test detail. So I have to get schema. Okay, so in the last hacker day, I talked about this need for get schema, and this is what you mostly do in production. And what do I mean by that? During production, you can actually infer schema from a data set. I mean, Spark gives you the ability to do that, especially from CSVs, right? Or pipe delimited or delimited files. You can infer schema, but that takes a lot of time, and especially for large data sets. Remember, these records were one record is 7 million test results, 7 million, and the test details alone they are about 8 to 9 million, right? You don't want to be doing that every single time. So this is what the better practice is you know what the schema of the data set you're dealing with, and you store it as in a schema form. I usually use JSON. So if you look at my application in the resource folder of my project, a Scala project, I stored the JSON file for all of them, so that from within my application, I will read these JSON files, right? I will read these JSON files and convert them to a Spark SQL schema, right? I convert them and I use them. So that is the reason why you see get schema from file. So we have a file and we're reading it and using that read to quickly infer into the structure of our data. Very important, especially when you are working with data that can change. So you want to externalize the schema and make it easy for you to evolve as fast as the data evolves. So that is what we did for test detail. And you can see, voila, it didn't take time. We have the schema. So if I say test details, the print schema, you have it there, and item group, the print schema, you have it there. So everything we did the previous time was to perform all this function. Now we have a data frame df1, the print schema. So you can see what I've done here is that I have merged the test. Let's show you this so you see that I have merged this test item details with a hierarchy of this four times hierarchy of this with this test item detail. And that is everything we literally did here, right? So the next move I'm gonna make is to create a table in Cassandra to match this guy, right? But before I do that, let's look. How many records do we have here, right? We have about 12,500, and this is a supplementary data. This is not the main data set. This is just supplementary data, but we can perform analysis on supplementary data. So look at this, you would see that we have 12,595, and we have this structure. So to cut the long story short, what I did was, if somebody always needs to access this data, the primary key definitely we want to use, since it's a lookup data, we want to stick with the primary key as specified in the ERD. Remember that in Cassandra, you don't just jump and take the model of an entity relationship or an entity relationship domain, right? Instead, you look at the use of the data. And what we decided the use of the data was from this query. We saw that the primary key here is what? Test class, right? So they say they want to get the hierarchy for classes, right? So the basic expansion of reason for refusal hierarchy by class ID. So we decided that this class ID is the primary key. And that led me to create a, so we'll look at the rest later. I just want to look at this. How did I create this? I actually took this, pasted it right here, copied and pasted, copied and pasted. This is integer, this is int, this is text. So I literally copied and pasted, and I declared the primary key as the test ID and the RFR So the test class ID is the partition key, right? And the RFR is the clustering key. So data within the test class ID partition will be sorted in the order of RFR right? So if you want upward descending and if you want a different order of descending, then you add a with clustering clause right here. But we don't have that, so I'm just going to copy this and paste it in our demo right here. Good. So if I say describe, not show, describe tables, and I'll have test item details. I can describe that as well, right? You can see I have with clustering order, RFID is ascending. Remember, this is partition key, this is clustering key, and you can see the clustering order for that. You can see it has its own Bloom filter, it has its own caching settings and compaction strategy, right? And it doesn't have its own. It's this is the order and this is the property of the table, right? So just to make this quick, we are now going to write this into that table. So we will say df data frame write to get a data frame writer. Now because we have an implicit object, so implicit, so because we have implicits, when we imported the Cassandra method, so you can see all the implicit functions right here. That's a lot of implicits. We can just do df1.write, and all of a sudden we have this thing called Cassandra format. So that is the implicit working for us. So I can say Cassandra format. Cassandra format is another way of using the format keyword, right? Then you say org.apache.spark.sql.cassandra. I think I'm right. Right? Let me confirm that. Spark. I'm right. So, but this is kind of long, and since I already have, this is correct. But since I already have the implicit, it does it for me, right? They're the same thing. Then I would say Cassandra format. Then I would say save, right? Let me be sure about that. Yeah, I think save. Let's look that up. Yeah, save. Save. That's the word, save. But this has a problem. The problem is we didn't tell it the table. So we're going to use options to tell you the table. So you can put the options here or here. I prefer to put it after the options. Options. So this should take, if you use option, then you can only put one, and this will be table. Name of the table is test item details. You can put another option, and this is let's get that. No, I choose to do something I did it before. Give me a second. Table and key space. That's the word I was looking for. Key space. So I'll use demo key space. So we hit enter. If we make any mistake, it's going to, we're going to have issues with it. But we expect it to work. So you can do it option, or you can do options and just pass in a map, right? A map in. When we do that, we will come to Cassandra and we say select count from, what's it again? Tests, item details, right? It's going to return, but it's going to complain. So we have our records in here, right? We have the records now in here. But you see, it's saying that you're writing a query without specifying the partition key. So it doesn't really know which node to send the query to. So you can see the question, anything you pass into Cassandra always wish that you pass in that primary key containing the partition key so that it knows which node should be handling that query. Right? We didn't do that, but it's okay. So we're going to stop here. That was quite a lot for the first day. And tomorrow we're going to pick up from there and look at the more really complex table and ask ourselves how to tackle it. We'll make conclusions along the way, but we want the conclusions to be influenced by what we're doing, right? So thank you and see you tomorrow.